This is lesson 18 for 7th grade, and today we're talking about polygons and the terms congruent and similar. This should be review, things that the students have seen before. We're basically talking about different shapes today and how we name those shapes depending on how many sides they have and angles and things like that. So we'll jump in here. It says, when three or more line segments are connected to enclose a portion of a plane, a polygon is formed. So the word polygon comes from the ancient Greeks and means many angles. So, specific names will tell us how many angles and how many sides a polygon has. So, for instance, a very common one, a triangle, has 3 sides. Quadrilateral, that's a 4-sided figure. Pentagon 5, hexagon 6, heptagon 7. And as we go on, we have different names. A very common one, octagon, like a stop sign. We see those all the time. It says to note here, because we only go through 12 sides. For polygons with more than 12 sides, we use the term n-gon, with n being the number of sides. Thus, a polygon with 15 sides is a 15-gon. So, if we are bigger than 12, that's the terminology we're going to use. That would tell us we have a 15-sided figure or shape. Oops. Alright, so where two sides of any polygon meet, or a corner, such as S, U, V, or T here, we call those vertices, plural. So U, S, V, and T would all be vertices of this quadrilateral. And in order to name a shape, we can just take those vertices and we can list them off in order. So this would be, if we were going clockwise, U, S, T, V, U, S, T, V. We can do this in any order that we want, as long as we're not skipping around. So we can't go U2, UT, VS, that wouldn't be okay. We need to make sure we're in order. So if we start at S, we either have to go here or here. So STVU or SUVT. So this has 8 different names that we could use. Alright? So as long as we're going in order, it's okay, from vertex to vertex. We just can't skip around when we name them. So 8 names for this quadrilateral. Now, things that are going to be important in the near future, we want to talk about the difference between regular polygons and irregular. Now it says, if all the sides of a polygon have the same length and all the angles have the same measure, then the polygon is a regular polygon. Regular polygons are much easier to work with. I like them a lot better, and they're much more symmetrical. They're more fun to work with. Irregular shapes, they'll throw you for a trip sometimes. You're not really sure what's going to become of them, but they're still pretty awesome. Anyway, regular means that all of our sides would be the same and every angle is going to be the same measure. So there's a couple examples of regular polygons. Just heads up, a regular quadrilateral automatically has to be the shape called a square, because a square has all 90-degree angles and all sides are the same. So that automatically has to be a square. Let's see. And the good thing about regular shapes is that we can actually figure out what each degree measure is for each angle. So if we look at a triangle, I know that all the angles add up to 180 degrees. So there are 180 degrees in this triangle, but there are 3 angles, and since they all have to be the same, if I just divide this by 3, we'll get 60. I know that each of these is 60 degrees, 60 degrees, 60 degrees, 60 degrees. That triangle becomes very important in the future with geometry and trigonometry, high school math, and actually we might even hit it a little bit this year. Yes, becomes very important. Quadrilateral, one way we can figure out how many degrees are inside here, I can split this up into 2 triangles, and I know that each triangle has 180 degrees, so 180 plus 180, total we should be getting 360 degrees. Now if we divide that by 4, we'll get 90, 90, 90, 90, 90. They all add up to 360. We can do that with any polygon. 1, 2, 3 triangles, so 3 times 180 would give us the total amount for each if we added up all the measures. We're not really getting into that yet, but that's something that we will be doing in the future. And just a little side journey there. And like I said, irregular angles are not the same, and the sides are not the same either. All right, one term that we need to talk about. Two figures are similar if they have the same shape, even though they may vary in size. So this one shows that 1, 2, and 3 are similar. They're all the same shape triangle, but they're all different sized. So these would be what we call similar, okay? So we'll find out later that they're all proportional to one another too. Alright? And if they're not similar, let's see. They don't have to be similar, but if they're not similar and they're not different, figures that are the same shape and size are not only similar, but they also are congruent. So if we do have two similar objects, there's a possibility that they could be congruent as well. Now congruent means that they are the same shape and the same size, so everything's the same. Now all three of these all look similar to me. They could all be similar because they're all the same shape. But these two right here, these are congruent. So all three of them are similar, but these two are definitely congruent because they are the exact same shape and exact same size. Later on in our mathematical careers, we'll be able to prove with numbers and angles and things if two things are congruent or not. And that's more so high school, but it's pretty cool. Alright. One other thing we need to hit, corresponding parts. So when inspecting polygons to determine whether they are similar or congruent, which we will do in the future, we compare their corresponding parts. Corresponding parts would mean if we look at these two triangles here, okay, which angle corresponds to B? Well, E does, because it's in the same position as B would be if we flipped it around. So these are, yes, they're flipped in different positions, but B and E are corresponding angles. Same with these two, A and D, and then C and F would correspond with each other. We could also do this with sides. AB corresponds with DE, that type of thing. So we'll look at an example of that. There are some easy ways to go about that. Alright, so if we look at these here, letter A, which of these quadrilaterals appear to be similar? Remember that similar means they do not need to be congruent, but they can be the same shape, but not necessarily the same size. So 1 and 2, they look like they could be similar, same shape, different size, and also quadrilateral number 4. So 1, 2, and 4. Those look like they're similar. Now, which of these quadrilaterals appear to be congruent? Well, 1 and 4 definitely look like they are the ones that look like they could be the exact same. Same angles, same side lengths, all that stuff. Alright? Now, if we look at this, we're talking about corresponding parts here. Which angle in triangle XYZ corresponds to angle A in triangle ABC? So we're looking at this angle right here. Which angle in XYZ corresponds to ABC? Well, it looks like it would be this one. That's in the same position. If we were to rotate things around, match everything up, we would say angle X. Alright? Which side in triangle XYZ corresponds to BC in triangle ABC? So we're looking at BC. Looks like it's the side opposite A, so it should be the same one opposite X over here. ZY, so we could say ZY or YZ, those two segments there. one way that we could have done this without even looking at a picture, they asked for which side in XYZ corresponds to BC and ABC. If they give you the triangle name, remember when naming things we have to match things up. So they were looking for BC. Well, the ones that should correspond to it will be the last two letters here. They have to match up. Everything has to be in the same order. So BC and YZ would be the two that correspond there. Alright, so this was a very basic intro and review to some of the basic polygon things, and we'll be getting into a bunch more as the year goes on, and especially once we get into high school. I will put the homework out on the link today, and we'll see you next time.